Humans, without a doubt the smartest animal on Earth. Yet we're unmistakably tied to our ape origins. Millions of years ago, we were apes living ape lives in Africa. So how did we get from that to this? What happened? What set us on the path to humanity? The questions are huge, but at last, there are answers. More than 6 million years ago, we took that first step to separate from the apes.
We see the launching of the career that ultimately led to Homo sapiens.
And 3 million years ago, we see the roots of our big brain begin to take hold in a tiny creature more like a chimp than a human.
The frontier of human evolution is really being brought to this razor-sharp edge.
And we now know that for millions of years, many different human-like species lived together on the planet, until one day, there was only us. Homo sapiens, the most complex, adaptable animal on Earth. So how did we get this way, and why? A radical new theory reveals how episodes of cataclysmic change forced our ancestors to adapt or die.
I think we should actually look to our proud ancestry and how we evolved in East Africa and say, that's how we survived that. We can survive the future.
So get ready for a ride through millions of years of our history. It's the story of becoming human. Our story, right now, on Nova.
Major funding for NOVA is provided by the following.
Millions of years ago, on the plains of Africa, a momentous event took place. Apes that had walked on 4 legs stood up and walked on 2. Eventually, this change in posture would be followed by a change in their brains. Somehow, over time, they would become us. We know it happened, but we've never known when or why. Until now. In the Sahara Desert, a 6-million-year-old fossil called Toumai may hold the secret of how we first walked upright.
We are writing the first chapter of human evolution. We are very close to the beginning, very close.
And the fossilized bones of a child from 3.5 million years ago hint to us about the beginnings of human thought. We're discovering how many different human species lived on Earth at the same time, and why all but one died out. We, Homo sapiens, are the first ever to be alone. So what powered our evolution? Why did we become human? Scientists are scouring the most remote parts of Africa for clues. The search for answers begins here, in the Afar, northeastern Ethiopia. It's part of the Great Rift Valley, a deep cut in the earth where geologic forces are ripping Africa apart. Millions of years of history are brought to the surface in layers of exposed rock. It's hot and desolate. Dangerous, too. Ancient rivalries and modern weapons have turned the Afar into a no-man's land of simmering conflict. But Zerai Alemzaghet has made this forbidding place his life's work. He's searching for the fossilized traces of our earliest human ancestors. The fossil bones of animals like antelopes, elephants, and pigs are abundant. But the fossils of our ancestors are extremely rare. Then, in a stroke of luck, Zerai makes the find of a lifetime. A find that illuminates our origins in a unique way.
On that afternoon, we decided to survey this hillside. And the first thing that was spotted was a cheekbone of the face.
It was a face so tiny, it had to be a baby. But not a baby chimp. He could tell that from its shape. The skull was embedded in sandstone, but as Zerai turned it over, he could see more bones inside.
Everything was squashed against the base of the skull and completely covered by sandstone block.
Clues to the age of the fossil came from a distinctive feature in the landscape. White bands of volcanic ash.
And that is the volcanic ash dated to 3.4 million years ago.
If the volcanic ash is 3.4 million years old, Zerai's fossil, which was lying just above it, must be younger. It was a child from the dawn of human evolution, about 3.3 million years ago. Zerai called the baby Salam, the Ethiopian word for peace. Then he set off on a quest to unravel her many mysteries. Her journey began a very, very long time ago. Imagine the entire span of recorded human history, taking us back to the Egyptian pyramids, about 5,000 years. Double it, 10,000 years ago, when plants were domesticated and agriculture begins. Double it again, to the time when Ice Age hunters paint stunning images on cave walls. And keep doubling, 6 more times, taking us back 1.3 million years, when the first creature who really looked like us hunted on the plains of Africa. And then keep traveling back another 2 million years, and only then do we arrive in the time when Salam lived in Ethiopia, nearly 3.5 million years ago. What were Salam and her family like? What kind of world did they live in? The answers are hidden in their fossil bones. Addis Ababa, Ethiopia. Zerai's home. He's one of a whole new generation of African scientists trying to unravel the mysteries of human origins. Zerai has brought his precious fossil here to the National Museum. His challenge is to release her from the tomb of sandstone in which her bones are encased. He quickly identifies her. She's from a species considered by most scientists to be an ancient ancestor. Australopithecus afarensis, a small chimp-like creature who walked on 2 legs. This is the same species as the famous Lucy, discovered in the 1970s by Don Johanson.
Lucy was terribly important because she was really an amalgam of different characteristics of ape and human.
I think specimens like Salam and Lucy are extraordinary simply because you can look at them and see evolution in the making.
But seeing evolution in the making will take some work. Salam's fossilized bones are solid rock, held together by a mesh of soft sandstone. it has to be painstakingly removed.
He spent hours and hours and days and years, and then removes the sand grains, grain by grain, working every day.
He's been at it for 8 long years, but the payoff has been amazing. As the work progressed, Zerai revealed an almost complete skull. And tucked beneath it was nearly her entire spine, along with both shoulder blades. Other bones were found nearby.
An almost complete foot. This is the kneecap. The tibia here.
Never before had a child's skeleton been found so ancient and so complete. Her bones would fit in a shoebox, but they speak volumes about her life. For example, to find out how old she was when she died, Zerai looked at her teeth, but not the baby teeth visible in her jaw. The adult teeth growing inside the bone, as seen in a CT scan. From that, we know Salam died at age 3. Like Lucy, she testifies to a crucial step in our evolution. Unlike apes, these creatures walked upright, as the first fossil Don Johanson found clearly revealed.
It was sticking out of the ground like that. And I gently tapped it with my sneaker, and this is what fell out of the ground. And it is this is the top end of your shin bone. So the kneecap would sit right in here, and very close by, in 2 pieces, I found this bone, and when you put them together, and you see how they move and articulate, that it has all the hallmarks of an upright person.
Other bones confirm that Lucy walked on 2 legs, like us.
This is Lucy's pelvis, and you can see how different a chimpanzee is, and the reorientation of these hip bones. In a chimp, they're facing straight forward. So this is what everybody's sitting on in their living room right now. So they're not identical, but clearly these 2 resemble each other much more closely, right? Than either one of these resembles the pelvis of an ape.
From the waist down, Lucy was like us. From the waist up, she and her kind were all ape. Salam's skeleton is the same, with chimp-like shoulder blades giving her the range of motion needed for climbing and swinging. These ancient creatures must have spent time in the trees, possibly sleeping there at night to keep away from predators, but walking upright on the ground during the day. They were at home in 2 worlds. What was their environment like? It must have been very different from the Great Rift Valley of today. Across the border in Kenya is one of the hottest and most barren places on Earth. A vast expanse of volcanic rock and burning desert. That's how it is now. But there's good evidence that for most of its history, it was very different. Researchers braving temperatures over 100 degrees are seeing signs of a dramatic transformation here in the Suguta Valley.
The Suguta Valley was entirely covered in water, up to an elevation of about 580 meters.
So you can imagine that all this valley was filled by a huge lake.
A huge lake that's deeper than any of the Great Lakes. In fact, the entire African continent used to be a lot wetter than it is today. Many millions of years ago, Long before Salam and Lucy, Africa was a wet tropical environment covered with rainforest. This is where the ancestors of Salam and Lucy lived. They probably looked a lot like chimps. But then Africa started to gradually dry out. The rainforest began to shrink. By Salam's time, 3 to 4 million years ago, the Great Rift Valley was a mosaic of different environments. We know that from the fossils of the animals that lived here. Their bones litter the ground.
This is a canine of a hippopotamus. So this is probably a skeleton of a hippopotamus. How can one find a hippo in this type of environment? Really nice antelope.
The
here.
fossils tell the story of a vanished landscape.
This is a lower jaw of an antelope.
3 million years ago, the Rift Valley was a patchwork of grassy plains, scattered woodlands, lakes, and rivers.
Definitely very different from what we see here today. Wow, a nice pig here.
As their environment changed, scientists believe our ancestors changed too. They had been creatures who spent most of their time in trees, like chimps and orangutans today. But as their forests shrank, some of them developed the trait that we take for granted: bipedalism, walking on 2 legs. This is one of the defining characteristics of humans. But how did bipedalism develop, and why?
Bipedalism is such an unusual trait. There's no other mammal that habitually walks on 2 legs like we do.
Because it's unique, it's hard to figure out why it happened. There are a lot of theories.
One of them is that they stood up to be able to see over tall grass. Another theory, they stood up to be able to pick fruits off of the low branches of trees, the way chimpanzees do today. Another theory states that they stood up to cool more efficiently so that we don't have as much sun beating on so much of our body.
And I think the most compelling idea, the most compelling hypothesis is that it saved us energy.
And energy is crucial to survival. Let's go back to the dense forest, home to our ancient ape ancestors 10 million years ago. Like many apes today, they were perfectly suited to a life in the trees.
They're very good at climbing in trees. They're phenomenal at climbing in trees.
On the ground, these ancestral apes could probably walk on 2 legs for short distances if they had to carry something.
Fantastic climbers, but also able to walk and run rapidly and effectively, but not economically.
Walking was tiring, but they didn't have to walk far.
But if you're a chimp and you only walk 2 to 3 kilometers a day, it doesn't really mean much, right? It's not going to have that much of an effect on your energy budget.
But energy demands would change as the forest started to disappear. Our ape ancestors had to walk more.
They have to go farther to get from one fruit patch to another fruit patch, for example.
Dan Lieberman is an expert on bipedalism. He believes that walking on 2 legs evolved because it saved energy. When you compare the energy consumption of humans to chimps, there's no contest. A chimp is an energy glutton.
It spends an enormous amount of energy, about 4 times as much energy as a human walking.
Whether it walks on 4 legs or 2, a chimp can't compete with the human gait.
it's poorly designed to withstand the forces of gravity. It has to spend a lot of muscular effort to keep itself from collapsing into a little pile of chimpness or whatever with each step.
According to Lieberman, small anatomical differences created large energy savings, setting our ancestors on the path to bipedalism, a path that would eventually lead to us. But how long did it take? When Lucy's kind were first discovered, many people thought they were the so-called missing link between apes and humans. But the science of genetics has transformed our understanding with a technique called the molecular clock. Today, scientists can compare DNA from closely related species to find out how long ago they split from a common ancestor.
It's just a very simple idea that the rate of change in DNA sequences is more or less constant over time. And that's an extraordinarily powerful concept because it means that you have a way of determining when two species last shared a common ancestor.
Living forms evolve because DNA sometimes spontaneously changes as it copies itself. These changes happen at a surprisingly regular rate. By counting the differences between the genetic code of chimps and humans, we can calculate how long they've been evolving away from each other.
The dates that one almost always gets are around 5 to 7 million years ago for when humans and chimpanzees last shared a common ancestor.
Here was proof that humans diverged from the apes much earlier than we thought, about 6 million years ago. It shows Lucy and Salam weren't one step removed from chimps, but many. They may even be closer to us than to the first human ancestor. So what came before Lucy and Salam? Who was our earliest ancestor? Until the 1990s, the fossil record was blank. Fossil hunters combed East Africa's Great Rift Valley, but could only find small fragments older than 4 million years. Then, in 1997, a French anthropologist called Michel Brunet decided to look somewhere else.
We decided to go to Africa, but to the west. To the west of the Great Rift.
1,600 miles to the west, at the edge of the Sahara Desert in northern Chad.
Obviously, if you only go to the field in East Africa, then you are going to find fossils only in East Africa. This was the situation.
Michel was looking in a place where the few animal fossils he turned up were all around 6 million years old. No one expected any human-like fossils to be found in a layer that ancient.
And everyone said, no, there just aren't any fossils there.
Michel was not to be deterred. He was stubborn, many thought to the point of madness. He and his team spent years searching the desert for signs of our ancestors, and year after year, they came up empty. Then, on their 26th expedition in 2001, they found a smashed, misshapen skull around 6 million years old. They called it Sahelanthropus chidensis. There were no bones apart from the skull. Could it be a human ancestor or just another ape? The skull was so deformed, it was difficult to tell. Michel would have to reconstruct it. His first step was to take the skull, now nicknamed Toumaï, to a particle accelerator in Grenoble, France, to use its powerful X-ray scanner. Over 1,000 pictures of the fossil were taken to build a 3D image of the crushed skull. Using the virtual image, the skull could be restored to its original shape. It was then reproduced by a type of 3D printer equipped with lasers which hardened plastic. When it finally rose from its bath, the cast of Toumaï's skull was ready for detailed study. The cast allows Michel to answer an important question. Did this ancient creature walk on 2 legs millions of years before Lucy or Salam? It's how the skull connects to the spine that provides the vital clue. And Michel could infer that from the shape of Toumaï's skull. If Toumaï's skull is set on the neck of an ape that walks on all 4s, his eyes point downward. That can't be right. Set on the upright spine of a biped, his eyes point straight ahead. For Michel, this proved Toumaï walked upright.
Anatomically speaking, he had a receding back skull of a biped. The back of his skull is not that of a gorilla, like some people are trying to say. No, not at all. All you have to do is look.
Some scientists still question whether Toumaï was really a biped. But if Michel is right, his 6 million-year-old fossil is a good candidate for the first human ancestor. Discoveries like this are changing the way we see human evolution. Scientists used to have a simple idea. The growth of open grasslands forced our ancestors out of the trees. They became bipeds, and in short order, brain size increased. Human evolution took off. We were on our way to becoming human. That simple idea prevailed for more than a century.
Darwin thought that we left the trees, walked on the ground upright, freed our hands, made tools, got big brains, reduced our canines, and so on, all at the same time.
But walking upright may not have automatically led to big brains at all. From Toumaï to Salam, both bipeds, brains stayed small. And they weren't the only ones. Over millions of years, there was a profusion of upright walkers with complicated names and chimp-sized brains, like Auroran tugenensis.
What we're seeing is a fluorescence of species, multiple species. They're probably subtly different from each other.
Ardipithecus ramidus.
But it's important to recognize that there are not major differences among these species.
Australopithecus africanus.
They were all bipeds, big snouts, more or less chimp-sized brains.
Kenyanthropus platyops.
This way of life, this suite of adaptations, lasted for millions of years.
Small-brained bipedal apes were extremely successful. Debates rage among scientists about which one eventually led to us. But as a group, they flourished for about 25 times longer than we've been around. They survived and thrived as brain size flatlined for almost 4 million years. But that doesn't mean nothing changed. There's evidence that the seeds of our humanity were growing in these ape-like creatures. One key difference between humans and apes is the length of childhood. But what do we know about the childhood of our early ancestors?
We knew all about the adult individuals, but we didn't know much about the children.
The brains of baby chimps have an early growth spurt. They're almost fully formed by age 3. In humans, that growth spurt is slower, and it takes nearly 2 decades for our brains to fully mature. But what about Salam's brain 3.3 million years ago?
But of course, most exciting.
Her skull tells us all we need to know.
At this place, this
We have her milk teeth
tells you.
and her adult teeth, which give us her age, 3 years old. And we have a cast of the inside of her skull, which tells us about her brain.
When you have this, you can directly measure how much of the brain was formed at age 3.
From other fossils, we know how large Salam's brain would have been as an adult. So Zerai could calculate how much of her brain was already formed by age 3 when she died. He knows what the answer would be for a chimp.
By age 3, a chimpanzee would have over 90% of the brain formed.
But Salam's brain was only around 75% of its adult size, suggesting it was growing up slower. Childhood would have been her time to learn the survival strategies her family group needed to live in a dangerous world. Perhaps this set the stage for our longer human childhood when culture is handed down. But is there any other evidence Salam's brain was becoming more human and less ape? To find out, compare a human brain to a chimp's.
This is the brain of our closest relative, the chimpanzee brain. It's slightly larger than you would expect of a typical primate for their body size, not greatly so. But there's a difference.
Scientists look for clues to the evolution of the brain in the folds and furrows on its surface. One important structure is called the lunate sulcus.
In chimpanzees, as in many primates, there's this big, deep sulcus here, the lunate sulcus.
The lunate sulcus is a deep furrow in a primate's brain. It divides parts of the brain related to vision from the rest of the neocortex, which is where more complex thought happens. The human brain doesn't have this deep furrow, and the neocortex is bigger than the vision structures, which have moved far to the back. So did Salam have the deep furrow and small neocortex of a chimp, or had something changed? Brains don't fossilize, but her remarkably complete skull provides a way to see some of the different structures of her brain. A cast of the brain case, called an endocast, preserves the impression of the brain's surface. Ralph Holloway has a collection of 300 brain endocasts from many of our ancestors.
What a paleoneurologist like myself will be looking for are those indications on the endocast that might suggest reorganization taking place. And that's why things like the so-called infamous lunate sulcus becomes important.
Ralph claims that as chimp-like ancestors evolved into creatures like Salam and Lucy, the lunate sulcus, the furrow marking the vision structures, moved back, making room for a larger neocortex, the thinking part of the brain.
If you look carefully, what you've got here is a depression that could very likely be the lunate sulcus. And so that suggests then by Australopithecine times that you're having a beast that is simply smarter than present-day chimpanzees.
If that's the case, although still the size of a chimp's, Salam's brain had been rewired. But there was a long way to go. She and her kind were still very ape-like. It would take another 1,000,000 years for the seeds of humanity contained in Salam's tiny frame to bear fruit. It's a time still shrouded in mystery. For almost 500,000 years, the fossil record is virtually silent. But in this blank period, something is happening. In 2.5-million-year-old layers, scientists begin to find something new. We might be tempted to call them rocks, but someone was shaping them. They are the first stone tools.
The way we know this is a tool instead of just a broken rock is that it's broken in a very particular way, breaking a flake off this way, this way, back and forth. So there is a method behind how this rock was broken in order to make it into a tool, and it's not a random method.
It's considered unlikely they were made by Australopithecus, Lucy's kind.
Australopithecus was around for a couple of million years and did not make stone tools.
But if not Lucy's kind, then who? The gap in the fossil record makes it difficult to say. But that's not surprising. Tools preserve easily. Bones, much less so. Finally, the skulls of a new creature begin to turn up. Is this the toolmaker? The skulls are different from what came before. They represent the dawn of a new era, beginning around 2 million years ago. This is our era, the era of the genus Homo, humans. The mysterious toolmaker, Homo habilis, is the first of these new creatures.
But we definitely have evidence that the stone tools were being used to break the long bones in order to get to the marrow inside the long bones. There were clear cut marks on the bones of turtles, crocodiles, big antelopes, little antelopes, even hippos, really big animals like hippos. So we know that meat had become a new important part of the diet of Homo habilis.
The first fossil to be called Homo habilis included 21 bones of the hand and was nicknamed Handyman.
This little bone is the bone at the end of the thumb. And that little bone in Homo habilis, like in humans, is very broad. And the broad bone reflects having a broad pad on the thumb with a lot of surface area for fine precision grip.
With newly dexterous hands, this creature could make better tools. But what was it like? The few skeletal bones that have been found indicate a creature much smaller than us, about the same size as Lucy and Salam's kind, Australopithecus, 3 to 4 feet tall. Homo habilis was still ape-like in many ways, but with a critical difference.
What we see in the evolution of Homo habilis is an expansion in the brain size compared to Australopithecus. So here is the skull of Australopithecus, and it has no forehead. It just has a straight slope behind the orbits. Whereas here in Homo habilis, you see a sloping, elevated forehead. And in Australopithecus, the area behind the orbits is pinched in, also reflecting a small frontal region. In contrast, in Homo habilis, we see an expansion of that area behind the orbits that points to an expansion in the cognitive capabilities of higher reasoning functions of the brain.
It was an expansion equivalent to a doubling of brain volume.
Once you go from something like 400 cc's in Australopithecines to, say, 700, 800 cc's in Homo habilis, yes, you're getting a big increase in cognitive capacity.
And along with his bigger brain, Homo habilis was starting to look a lot more human. The contours of fossil skulls allow reconstructionist Victor Dieck to reveal the faces of early human beings. Gone is the projecting snout of an ape. In Homo habilis, the face of humanity is emerging. This poses a great enigma. Why, after millions of years of flatlining, did brain size and mental capacities suddenly take off? Two million years ago, what jump-started human evolution? Scientists all over Africa looked for clues. Here in Kenya, they found some. At the southern end of the Great Rift Valley. It's a hotbed of tectonic activity where ancient layers are forced to the surface. 10 million years ago, Africa was a much wetter place. A tropical jungle which has been slowly drying out ever since. But these rocks in Kenya show that Africa's gradual drying trend was punctuated by bursts of wild climate fluctuation. Rick Potts is an expert in reading the rocks.
This layer right here represents about 1,000 years of environmental stability, but then we had an abrupt volcanic eruption, and then the lake was around for perhaps 500 years before a drought, and then the lake came back. So in some cases, we saw this through layer after layer of environmental change.
With his trained eye, Rick could see some layers were once lake beds, others desert sands. Still others came from volcanic eruptions, a snapshot of 1 million years of climate history. This observation led him to an amazing new idea: rapid change as a catalyst for our evolution.
And I began to think that, well, maybe it's not the particular environment of a savanna that was important, but the tendency of the environment to change.
Could it be that the need to survive violent swings of climate made our ancestors more adaptable? A group of scientists has come here from Germany to find out just how radical these swings of climate really were. It's hard to believe, but these huge rock formations are made of the shells of tiny one-celled organisms called diatoms. There are many different kinds, but they all live in water. Their shells collect in layers of rock that pile up over millions of years, proving that this whole valley was once a giant lake. Annette Junginger analyzes these rock samples under the microscope.
What I've discovered was that those white layers consist of a special kind of diatoms which only live in deep lakes.
But between the white layers, she also finds other species of diatoms which only live in shallow water. It means that in this spot, a massive lake appeared and disappeared and reappeared many times.
These lakes are really significant. These are not small little ponds. And what we've been able to document now is a series of lakes that are cycling.
When we're talking freshwater lakes, the size of Lake Victoria, filling the whole Rift Valley and then disappearing.
An enormous amount of water rushing through this area.
This constant flux of turnover, of change.
An awful time to live here.
It's not just a unidirectional change, it's going back and forth.
Against the backdrop of a slow drying trend, Africa was periodically pulsing with climate change. Wet, dry, then wet again, sometimes in the space of 1,000 years. Punishing drought alternated with storms and monsoons. Rivers and forests sprang up, then turned to dry grassland, all in the evolutionary blink of an eye.
So we have a complete change of our ideas, from this slow drying out to this incredible change between wet and dry, wet and dry.
What effect did that have on our ancestors? Could these periods of climate instability be the key to understanding the evolutionary leap from small bipedal apes to the larger-brained toolmaker, Homo habilis? To know that, scientists needed a detailed record that went back further than the diatoms, way back to the time when Homo habilis was evolving 2 million years ago. That's only found in one place, under the ocean. Layers of deep-sea sediment tell a story that goes back millions of years. They have to be drilled from the ocean floor. At his laboratory in upstate New York, Peter Domenico keeps thousands of columns of sand, silt, and rock, a library of ocean cores.
One of the really attractive features about ocean sediments is that they accumulate very slowly, but very gradually and continuously over time.
Each 3-foot-long core holds a continuous record of dust carried on the wind from Africa into the ocean, where it now sits on the bottom.
There we go, nice! There you go. Wow, sweet, okay.
An expert eye can detect distinct layers, thick in dry years when the dust is easily picked up by the wind, thin in wet years. By measuring the layers, they can tell when the climate was wet or dry.
So we can read these deep-sea sediments almost like an Earth history book of past changes in climate.
To make sense of all this dirt, they have to know when it blew into the ocean. They can do this by dating the shells of tiny sea creatures that sank to the bottom at the same time.
So this gives us an age, the other analysis gives us the climate. There we go, nice!
Peter took this finely detailed climate diary and compared it to the grand arc of our human evolution. For the 3 million years between Toumai and Salam, when brain size was flatlining, African climate was stable, dry, getting a little drier. Then came 200,000 years of wildly varying climate, careening unpredictably between wet and dry. During that time, stone tools appeared, along with the larger-brained creatures that made them. Africa was also home to many other human-like species. Climate instability put pressure on all of them.
So there are these time periods when African climate was really unstable. So anything that was living there at the time would have had to adapt to really dramatically different climate changes.
Those that couldn't adapt died out, like Salam and Lucy's kind. Better problem solvers, like Homo habilis, survived. The new discoveries about ancient climate upheavals in Africa have led Rick Potts to formulate a bold theory of human evolution.
The traditional idea we have had about human evolution is that it was the savanna, the grassy plain with some trees on it, that was the driving force. But instead, what we've discovered is that climate changed all the time. And so the idea that we've come up with is that variability itself was the driving force of human evolution, and that our ancestors were adapted to change itself.
It's a simple but revolutionary idea. Human evolution is nature's experiment with versatility. We're not adapted to any one environment or climate, but to many. We are creatures of climate change.
I think we should actually look to our proud ancestry and how we evolved in East Africa and say, that's how we survived that. We can survive the future. because we are that creature, because we are that smart.
Today, climate change seems to threaten our survival. But it may have held the keys to the astonishing story of how we became who we are. Because it didn't stop 2 million years ago. These dramatic upheavals would continue for another 1.5 million years, propelling our ancestors down a road leading ultimately to the smartest creature the world has ever known.
Over 4 million American children are taking behavior-modifying drugs. Are they safe? Effective? Are these drugs the only answer? Stay tuned for The Medicated Child on Frontline, next at 8, here on MPTV HD10.1.
Or call 1-800-PLAY-PBS.
Humans, without a doubt the smartest animal on Earth. Yet we're unmistakably tied to our ape origins. Millions of years ago, we were apes living ape lives in Africa. So how did we get from that to this? What happened? What set us on the path to humanity? The questions are huge, but now there are answers. At the threshold of humanity, one ancestor contains tantalizing secrets. It is known as Homo erectus.
Homo erectus had a slightly smaller brain, slightly bigger jaw, but it's basically us.
Basically us, almost 2 million years ago. New finds are revealing the truth about the ancestors at the heart of our evolution. Here were the trailblazers who first left Africa, the first fire makers, the first hunters.
These creatures were capable of analyzing possible uses of tools and coming up with a technological solution to the problem of how do you kill a big dangerous animal without getting killed yourself.
Homo erectus pioneered what it means to be human, colonizing whole continents and creating the first human societies.
Our ancestors began to care about what others thought and care about what that individual thought about them.
Now, new discoveries are bringing them alive as never before. At last, we come face to face with the ancestors at the birth of humanity, right now on Nova.
Major funding for NOVA is provided by the following.
The Great Rift Valley of East Africa. 2 million years ago, these spectacular plains and canyons witnessed a mysterious event. The birth of the first ancestor we can really call human. New discoveries are revealing a creature surprisingly like us. A world traveler, a toolmaker, a hunter, tamer of fire, creator of the first human societies. Amazingly, the qualities that make us human began not with our own species, Homo sapiens. The true birth of humanity began much further back in time, millions of years ago. Imagine the entire span of recorded human history, about 5,000 years. taking us back to the Egyptian pyramids. Double it, 10,000 years, to the time when plants are domesticated and agriculture begins. Double it again, 20,000 years. Ice Age hunters are painting stunning images on cave walls. And keep doubling, 6 more times. Only then do we encounter our ancestor, Homo erectus, in Africa's Great Rift Valley. For millions of years, this massive geological fault line running the length of East Africa was a stage on which our human evolution was played out. It all started with the first apes to walk upright on 2 legs, about 6 million years ago. There were many different types, all variations on the same theme. Ape-like creatures with small brains. The fossil known as Lucy is the most famous example. Here she is, just 3 foot 8 inches tall, with a brain the size of a chimp's. For millions of years, creatures like her roamed the forests and grasslands of Africa. But then, something changed. About 2 million years ago, new creatures appeared with abilities never seen before in the animal kingdom. Meet Homo erectus, a toolmaker and hunter. One of the first members of our genus, the genus Homo, humans.
The transition to Homo was probably one of the most important transformations that occurred in human evolution.
Arms got thinner, legs got longer, brains got bigger. It was a huge evolutionary step from ape bodies to bodies like ours. But what about the things that make us distinctly human? Creativity, intelligence, caring for each other. How can we know when these got started? With only skulls and bone fragments to go on, how could we ever know what those first humans were really like? It would take a momentous find to shed light on their lives. Lake Turkana, northern Kenya. Surrounded by volcanoes and vast expanses of baking desert. In 1984, famed anthropologists Richard and Maeve Leakey were working at this remote inland sea.
I was actually on the east side of the lake, and then Richard flew over and said, "You've got to come, there's something really exciting."
As the first family of paleoanthropology, the Leakeys were used to fossil finds. But this was very special. One of Leakey's team had found a skull fragment of one of those early humans. He could tell from its size and shape it was Homo erectus. And there was more than just a fragment.
So we started looking at this site on a more extensive basis, and of course, once we did, we found the rest of the skull.
A complete skull was rare enough, but it was just the beginning. Soon, parts of the Homo erectus skeleton, which had never been found before, started to emerge.
We couldn't believe it, but we started getting pieces of ribs. These were parts of Homo erectus that nobody actually knew about, nobody had ever seen before. So every bone that came out of the ground was something brand new to science, and we were looking at these things, and it was really amazing.
And here they are, the actual bones of a human ancestor who lived over 1.5 million years ago. It's the earliest human skeleton ever discovered. The Leakeys called him Turkana Boy. His bones have revolutionized our understanding of the transition from ape to human.
The really important thing about Turkana Boy is how complete he is. We've got arms and legs and bits of his spine and his ribs. And usually when we find these things, we get very excited about one little bit of bone. But that little bit can't tell us very much about an individual. So having a nearly complete skeleton, we can start to ask big questions.
The first big question was, what did he look like? His skeleton tells us he was 5 feet 3 inches tall, with a build closer to a man's than an ape's. But how close? Paleo artist Victor Dieck specializes in painting and sculpting our human ancestors with precise anatomical accuracy. Victor's going to add Turkana Boy to his family of ancient faces.
At this stage of the game, I know that Turkana Boy is not an ape. He is a very early true human. And so here we have a modern human skull. The faces are very similar to one another, but Turkana Boy's skull is a bit more primitive and has a lower forehead and a much smaller brain capacity.
Victor will build Turkana Boy's face muscle by muscle, based on his studies of cadavers and modern anatomy. While his head may be primitive, Turkana Boy's skeleton is surprisingly human. His hips are a little wider, his arms a little longer, but his overall body shape is just like ours.
Turkana Boy and Erectus, that's something that if you were to see from 100 feet away, you would think, well, there's a large naked man there, or woman, or you know, but it's a human.
It will take Victor a week to flesh out Turkana Boy's face. Meanwhile, a team of animators is at work creating scenes that will bring Turkana Boy and his people to life. To make sure they do it accurately, they have enlisted the help of Harvard anthropologist Dan Lieberman.
They had a more forward position of the palms when they ran. Just slightly. There you go.
The blue-suited actors are there to create movement references for the artists. In the final animations, they will be replaced by Homo erectus bodies.
And action!
Their heads and faces based closely on Victor's model. As Turkana Boy's forensically reconstructed head nears completion, a face emerges that looks a lot like us. Now, for the first time in 1.5 million years, here he is, our ancestor, the Homo erectus, called Turkana Boy. But what he looked like is only the beginning of his story. To reconstruct his life, we need to find out how old he was.
And if we look at his skeleton, we can see that the growth plates on his limbs that would fuse when he's fully adult are all unfused. So even though he's very tall, we know that he's still growing.
The fact that Turkana Boy was not fully grown has turned out to be a boon to researchers.
You can answer questions like, did the boy grow up like a modern human? Or did he grow up more like an ape?
Turkana Boy was already 5 feet 3 inches tall.
When scientists compared his bones and teeth to ours, he seemed to be about 14 years old. But when dental specialist Chris Dean began to study his teeth, he was in for a shock. It turns out that all teeth, fossil or not, preserve a remarkably precise record of childhood.
This is a fossil tooth, and we can see the enamel cap, which covers the core of the tooth, which is made of dentine. Dentine is just another word for ivory. And within the enamel, you can see the rods, which are running from the enamel-dentine junction here out to the surface of the tooth.
Enamel has a regular growth pattern like the rings of a tree. Under an electron microscope, it looks like rods made of tiny beads.
Each of the little beads along these prisms represent one day's growth, because the cells which produce enamel are actually under the influence of a circadian or daily clock. And those secretions during the day speed up and then slow down, and there's a permanent record of that in every tooth. So you can see rods running all the way through this tissue, and every day along the rod there is a wobble where the tissue slows down and then speeds up.
So if you count the beads in these strings, you can figure out exactly how many days that tooth has been growing. When Chris looked at the fossilized teeth of Turkana-Boy, he got a huge surprise. Turkana-Boy wasn't 14 years old, he was 8.
What that implies is that the growth of the Turkana-Boy resembled more closely that of chimpanzees today.
To be 5'3" at age 8, Turkana-Boy must have grown up very fast, at a rate closer to chimps than us. A chimpanzee's childhood is short. It is sexually mature at about 7. Human childhood is longer. We reach puberty at about 12. So as humans evolved from apes, childhood was extended. But what advantage could be gained by having helpless children around to feed and care for who take so long to grow up? The mystery of prolonged childhood is at the heart of human evolution. It may be related to brain size. We humans have the biggest brains in the animal kingdom in relation to our body size. They're so big that most of our brain growth has to happen outside the womb, or our heads would never get through the birth canal. A long, slow childhood gives our brains time to grow after birth, and time to learn everything we need to function in our complex human societies. That's the advantage of prolonged childhood, for us at least. But what about Turkana-Boy? His brain was 900 cubic centimeters, smaller than ours, but more than twice as large as a chimp's. So was he on the way to thinking and talking like us? Ralph Holloway believes he was. He's been collecting the brain endocasts of human ancestors for over 30 years. An endocast is a mold taken from the inside of the skull, which reveals the shape of the brain. Ralph is particularly interested in something called the Broca's area.
Broca's area is involved with memory functions, executive functions, but it does have a very important role to play in the motor aspects of speech.
In the brain of Turkana-Boy, Ralph believes he sees evidence for something remarkable. A change in the Broca's area tied to communication.
Broca's caps regions on the Turkana-Boy are fully modern in terms of their appearance. It is good, solid evidence for having the ability of symbolic communication. In other words, language.
It's a controversial idea, and we'll never know for sure if Turkana-Boy could speak. But there are other clues to his intelligence. The stone tools he left behind.
Homo erectus made tools like this hand axe here. It's been chipped extensively on both sides. The point enables one to do piercing tasks. The heavy bit here can be used for cracking bone or chopping wood. It's a very, very versatile tool and a sharp one.
It may not look like much, but the stone hand axe marks the birth of technology. Homo erectus has left us many signs of his inventiveness. Here in central Kenya, Rick Potts has been studying a treasure trove of Homo erectus stone tools.
Stone tools represented a momentous change because once you had tools in your hands, all the foods in the world could open up to you. That represented a tremendous survival advantage.
Here is a cache of over 500 stone hand axes made by Homo erectus. Just a mile away, Rick visits the quarry where for thousands of years, these ancestors came to shape stone into tools, leaving behind unused fragments.
In the crevices at my feet, there were thousands of fragments of stone from tool making. And there were several scars where Homo erectus struck huge flakes. We also see evidence that they could recognize flaws. They could see which ones would break if they took them away. So they simply discarded them here. What's amazing about that is you could imagine an early Homo erectus sitting right here making decisions.
The kind of decision-making it takes to create a stone tool has been researched extensively by John Shea.
I'm just going to tap it a little bit. I'm just checking it out to see if there's any internal flaws before I do it. There may be one in here. It feels like there might be something in there, but I like a challenge, so I'll map it anyway.
Even for an expert, making a hand axe is not easy.
Yeah, there's the flaw, but we got around it.
A good toolmaker has to understand the properties of stone.
To make this thing nice and thin, easier to carry, easier to transport, and more of the sharp cutting edge, I'm going to do something kind of counterintuitive. I'm going to dull the edge so that the next time I strike it, it won't fail until I have a lot of pressure on it. Until I've hit it really hard, the fracture will go much further than it otherwise would. So that Homo erectus did this tells us they were capable of thinking ahead, of planning the consequences of their actions. So let's have a look here. What'll happen here?
Many of these stones have hidden defects. Okay. Failing to spot them could spell disaster.
There's still a flaw in there. I can hear it. I can tell, yeah, see this? It's right there. Now, I've worked around it, but if I were an early human and spotted this, I would stop making the hand axe right now. If I'm out running around the savannas chasing a rhinoceros and, I'm butchering a rhinoceros as the lions are circling and my hand axe breaks, I'm in trouble. So, I go home tonight, I'm still going to get fed even though I didn't make a perfect hand axe. As Homo erectus, I might end up being the meal instead.
A skilled craftsman, Homo erectus had evolved a new type of intelligence. But his bigger brain came with hidden costs. Modern brains consume 25% of our body's energy.
Our brain happens to be the hungriest organ in the body. And in order to support a brain our size, we need lots of calories.
With his big brain and body, a Homo erectus like Turkana Boy needed more nutrition from his savanna environment.
Turkana Boy, had he grown to adulthood, would probably stood around 6 feet tall. This is a big, strong creature that would have had a huge energy budget. One can satisfy an energy budget like that by eating plants, but you have to eat a lot of plants.
But there's one food that can supply the nutrients a growing brain and body need, and Africa was filled with it.
The one high-quality resource that's probably most important for the evolution of the genus Homo is meat, and meat products such as brain and marrow and fat. They're high in protein, they're high in calories, and they're easy to digest. But the one problem with getting meat is that it's hard to get.
Most predators rely on strength or speed to kill their prey. Our ancestors had neither. Today, we are on top of the food chain, so it's hard to imagine the predicament of those early humans. Here was a slow-moving creature with no claws or fangs, easy prey for the hungry predators around him.
This is a fossil forehead and brow ridge of a Homo erectus. And on the brow ridge, you can see the bite mark of a carnivore. Well, this reminds us that these Homo erectus individuals weren't at the top of the food chain.
So how did Turkana Boy, a weakling with a big brain which needed calories, get his meat?
Homo erectus faced a problem. How do you kill a big, dangerous animal that has lots of meat and fat in it without that animal also killing you?
I think the answer to that was a very clever set of innovations, and that is endurance running and high activity in the middle of the day.
The ancestors of Homo erectus, small, hairy apes like Lucy, were bipedal, but probably didn't do much running. But Turkana Boy's kind were built to run, like us.
This is an accelerometer. It weighs
Dan Lieberman believes they could run long distances because, like us, they had lost their thick coat of body hair and could keep cool by sweating. This was the key to their success. But how do we know if these crucial changes go back all the way to Turkana Boy's time, over 1 million years ago? Skin and hair are rarely preserved in the fossil record. So to find out, we have to look to a creature that's been intimately connected with hair for a long time, the louse.
All animals seem to have some type of lice that parasitize them. Mammals have them, birds have them, even fish have types of lice. But most other creatures have only one type of lice that parasitize them.
Humans have one kind of louse on their heads and another in the pubic area. Geneticist Mark Stoneking asked himself why.
The answer that seems obvious is that when we had body hair all over our bodies, we had one type of lice, but then we became hairless until we only had hair on our heads and in our pubic region. And so therefore you would have this hairless geographic barrier to contact between the two.
Mark was surprised to find out that the human pubic louse is very different from the human head louse. Somehow, in the past, it seems to have come from gorillas.
Because the pubic lice is actually more closely related to gorilla lice. Now, how it is our ancestors got pubic lice from gorillas, I wouldn't care to speculate. But nonetheless, one needs gorilla lice in order to really work this whole thing out.
The most likely scenario is that when we lost our body hair, the original human louse migrated to our heads, leaving the pubic area temporarily unpopulated by lice. When our ancestors had contact with gorillas, perhaps sleeping in their nests or scavenging their bodies for meat, the gorilla louse colonized their pubic region. Eventually, it turned into the human pubic louse of today. So if we could find out when the human pubic louse and the gorilla louse diverged, we would have a rough idea of when we lost our body hair. Fortunately, there's a way to figure that out. The genetic dating technique known as the molecular clock. It's based on the fact that the sequence of chemical bases which make up DNA mutate at a regular rate.
It's just a very simple idea that the rate of change in DNA sequences is more or less constant over time. And that means that you have a way of determining when two species last shared a common ancestor.
By counting the number of differences in the genetic code of two species, scientists can determine how long they've been evolving away from each other. When Mark used the molecular clock to count the differences between the DNA of gorilla lice and human pubic lice, he came up with a date for their divergence.
The estimated date for the divergence is roughly 3 million years ago.
That means long before Turkana-Boy, maybe even around Lucy's time, our ancestors had slowly begun to lose their body hair. Turkana-Boy was mostly hairless, just like us. And that may be what gave him an edge over other predators. Most animals are at a disadvantage in the midday sun because they overheat. They can only cool down by panting. And when they run fast, they can't pant. That means they can only run in short sprints.
Quadrupeds can gallop for about 10 to 15 minutes, and then they overheat. But hominids can cool down by sweating. They use their entire body like a dog's tongue.
Our hairless bodies allow air to circulate freely on our skin and cool us down as sweat evaporates. This makes us one of the best long-distance runners in the animal kingdom. Dan Lieberman believes this gave our ancestors the ability to hunt in a very unusual way. It's called persistence hunting. And he believes the modern ethnographic record can show us how it was done. The Bushmen of the Kalahari offer us an insight into how Homo erectus might have hunted 2 million years ago. The Bushmen know that at midday, animals rest in the shade, which is why it's the perfect time to be hunting. Once they locate their prey, in this case a kudu, the marathon begins. Their strategy is simple. run it to exhaustion. Every time the animal tries to rest, the hunters track it down and get it moving again. They never give it a chance to cool down. And the reason they can keep going is that they can sweat. So if the theory is right, the Bushman hunt may help explain how Turkana got his meat. Homo erectus had come up with an innovative way of feeding his hungry brain. In this modern hunt, the Bushmen ran in the fierce heat for over 4 hours. The kudu was finally immobilized by heat stroke. Turkana wouldn't have had steel-tipped spears like the Bushmen, but he wouldn't have needed them.
Homo erectus probably hunted with close quarters weapons, with spears that were thrown at animals from a short distance, clubs, thrown rocks, weapons like that. They weren't using long-distance projectile weapons that we know of.
The Homo erectus hunt was simple but effective. It fed not just their larger brains, but the growing complexity of that early human society. There are other social animals, but none quite like us. Society is in every corner of our lives. Our relationships, communication, rules, symbolism, all the things that bind us together. What's behind it? Why do we become so social? Could it have something to do with another innovation? Something unprecedented in our evolution. Building fires and cooking.
Here we've got erectus, the first species that looks like us. And I think only cooking can explain the magnitude of this change.
The earliest evidence that our ancestors deliberately used fire for cooking dates to long after Turkana time. But Richard Wrangham is sure Homo erectus was building fires much earlier.
Now, for the first time, we had a species that was committed to living on the ground because they lose their climbing adaptations. Well, how were they sleeping? They had to be able to protect themselves from wild animals.
On the African savanna, full of predators who hunt by night, Richard believes Turkana and his people couldn't have survived without fire. And he thinks only cooking, which makes food more soft and digestible, can explain why Homo erectus evolved smaller teeth and a much smaller gut.
These things are compatible with the reduced cost of digestion produced by cooking food. Nothing else is.
As our ancestors reaped the benefits of cooking, something else happened too, at least according to Wrangham. We became more social.
Humans have this wonderfully calm temperament compared to chimpanzees, say. Where did it come from? We were drawn to a common place, the fireplace.
Wrangham believes we learn to share and communicate, sitting around fires, waiting for food to cook. It's speculative, but one thing is for sure. In the Homo erectus world, new social relationships had to be evolving. The bonds between mothers and children must have been very different from the apes.
For example, a mother orangutan will not allow any other individual to take her infant, will be in constant skin-to-skin contact with that baby for at least the first 6 months of life, not a moment out of contact.
Secure in this unbreakable mother-infant bond, ape babies need less capacity to read the intentions of others than human babies, whose bond with their mothers is surprisingly less secure. The shocking fact is that human mothers abandon their infants much more often than ape mothers. Infanticide by a mother is more common among humans than any other higher ape.
Maternal commitment is a lot more contingent in humans than it seems to be in other apes.
Unlike most primates, human mothers share parenting with others. A child's survival can depend on making itself appealing to a number of caregivers. Perhaps that's why human infants have evolved a uniquely acute sensitivity.
Human infants are born connoisseurs of mothers, reading her facial expression, looking for signs of commitment.
We are born hardwired with an awareness of the intentions and emotions of others, which is unique in the animal world.
When did humans develop this gift for attributing mental states and feelings to others and for caring about what others thought about them?
Could these social instincts have developed with Homo erectus? Along with cooperative hunting, bigger brains, longer childhoods, and the use of fire. Perhaps Turkana Boy and his people already had social skills that would be familiar to us. Here were intelligent social beings with an increasing capacity for cooperation. It may be this that made possible another great achievement, the exodus from Africa. For millions of years, our earliest ancestors stayed on the African savannas. But at some point, they started to leave. Ancient fossil skulls and tools have been found as far away as China and Indonesia. The question is, when did they leave Africa and why? When Turkana Boy was found, scientists thought they had the answer. Here was a strong, large-brained ancestor capable of an arduous migration. He had the look of a world conqueror.
In the mid-1980s, we were thinking that a hominid like this one had left Africa, but had done it maybe about 1 million years ago.
For decades, scientists believed big strapping humans like Turkana Boy left Africa 1 million years ago. But new discoveries are showing the migration may have started a lot earlier than that. Dmanisi, Georgia. The mountains and plains of the Caucasus, thousands of miles from the Great Rift Valley, had never produced any fossils of early human ancestors. But then, an astonishing discovery was made.
It was a lower jaw with teeth downward, this way in the ground. So when I started to clean, those front teeth came to light. It became obvious to me that we had found some kind of hominid. But what kind?
The jaw seemed to be a primitive form of Homo erectus. But at first, hardly anyone believed it.
In '91, when we found this jaw, a lot of scientists were quite skeptical about it. Because it was very hard to imagine Georgia, Caucasus, to be on the map of the human evolution.
Since then, Dmanisi has been put on the map of human evolution in a big way. The site has turned up a treasure trove of Homo erectus fossils. They've transformed our understanding of who left Africa and when. They showed that the first humans to leave Africa were much more primitive than Turkana Boy.
People thought that hominids that left Africa were very tall, like Turkana Boy, with big brains, advanced technology, and Dmanisi proved the opposite.
At 4.5 feet tall, they were smaller than Turkana Boy, with more ape-like shoulders and a simple stone technology.
They are much more primitive, they have small brains, and at the same time they were using very primitive stone tools.
The next surprise came when they dated the site. ancient Dmanisi landscape has been built up layer by layer over millions of years. 1.81 million years ago, massive volcanic eruptions deposited a layer of ash. The fossils sat on top of this ash, so must have been slightly younger, around 1.8 million years old. To the vast majority of scientists who believe that all our ancestors evolved in Africa, this was a stunning surprise. How had a small, primitive Homo erectus migrated to the Caucasus almost 2 million years ago, long before Turkana-Boy? Scientists now accept that as soon as Homo erectus appeared on the savannas of Africa, they started to leave.
Suddenly, with the origin of Homo erectus, we get this shift in body shape, and then boom, they're out of Africa right away.
The Georgia fossils prove that Homo erectus left Africa much earlier than previously thought. An even more provocative find shows the migration may have started even earlier. 5,000 miles from Africa, the island of Flores, Indonesia. In 2003, researchers made a discovery so strange, nobody knew what to make of it. They found the bones of a tiny human ancestor, just over 3 feet tall, even smaller than the Dmanisi fossils. They called this baffling new ancestor Homo floresiensis, and because of its tiny size, nicknamed it the Hobbit.
This has created a tremendous amount of grief because we're not really sure what we're seeing here. The size of the Hobbit brain endocast is roughly 400 cc's.
That's barely bigger than the brain of Lucy, the famous bipedal ape from 3 million years ago.
It's not just a small brain and a primitive-looking face, but the foot's primitive, the hand's primitive, the leg is primitive.
The lower limb is very much like the Lucy skeleton. That was a big surprise.
And in the cave where this primitive creature was found, they also uncovered stone tools, something Lucy never had.
People have for a long time said, well, you need a big brain to make stone tools. Well, okay, if Homo floresiensis is making stone tools, this creature has a brain the size of an orange. Clearly that equation's gone.
Everything about these creatures is an enigma. Where did they come from, and what were they?
Some researchers have argued that floresiensis is just a dwarfed population of modern people that suffered some kind of disease that caused them to both dwarf and have relatively small brains.
But when scientists took a closer look, most saw no evidence of disease. The stone tools and the shape of the face moved the focus to our old friend, Homo erectus.
Some researchers think that Homo floresiensis evolved from Homo erectus.
But how did they get so small? Something called island dwarfism may be the answer. Isolated on islands with limited food, large mammals sometimes shrink over time. On Flores, there were once pygmy elephants the size of cows. Could the same evolutionary pressure have acted on Homo erectus to produce the Hobbit? Or was this mysterious creature descended from an even more primitive ancestor?
So perhaps we're sampling a period which is at the very beginning of the Homo lineage.
So whatever the Hobbit was, perhaps its ancestors were the very first wave of migration out of Africa. Some unknown creature, part bipedal ape like Lucy, and part Homo erectus.
So if that's the case, then what we see in Indonesia makes sense. It's kind of a body that existed before human bodies became more modern.
What would push such primitive creatures out of Africa? A key driving force behind the migration was probably a climate shift, which spread grasslands from Africa into Asia. And with the grasses went the game animals.
Animals are going to be moving out of Africa, and the hominids will just be keeping pace with those animals. After all, that's their livelihood.
Of course, our ancestors didn't know they were leaving Africa. They just followed the animals they depended on, through the Sinai up into the Middle East and beyond. It's often been called an exodus, but it really wasn't like that.
When people think of Exodus, they think of the Bible, or they think of migration, they think of Europeans coming over here to the New World. It probably wasn't like any historical migration, this dispersal of humans out of Africa.
The process was probably very, very slow, much like the spread of any other animal species into new territories.
You could imagine a group of Homo erectus moving their range 1 kilometer a year in one direction, and doing that continually over a long enough period of time, you can get the distance from Africa to Indonesia covered in, say, 15,000 years.
By 1 million years ago, our ancestors had populated Asia from the Caucasus to Indonesia. And they were in Europe too, as a recent discovery in Spain has shown. Homo erectus had conquered the old world. The fact that they made it so far with limited technology and relatively small brains makes them seem even more remarkable. And their longevity was astonishing. A few pockets of Homo erectus may have been still clinging on in Asia just 50,000 years ago. That's a span of 2 million years. Our own species has only been around for 200,000. What was the secret of Homo erectus's success? The amazing finds at Dmanisi have given us one last clue. One of the skulls belonged to an old man. His jawbone revealed he had lost all his teeth well before he died.
That was a real surprise. It means that this individual survived 2 years without teeth.
For an elder to have survived that long without teeth must mean that others in the group were feeding him, perhaps even chewing his food for him.
I love this story. This was a remarkable testimony from the past about the quality of emotional life that may have characterized Homo erectus.
Here is a tantalizing clue to what may be this ancestor's most important legacy: the instinct to look after each other. And it helps us imagine Turkana Boy's final day on Earth. In the animator's scenario, he starts the day out on a hunt. But he has trouble keeping up with the hunting party. Why? The evidence from his skeleton is that he was sick and in pain at the time he died.
If we look at his lower jaw, we can see right here under the teeth that we've got a bit of an abscess and an infection. That kind of an infection could have entered the rest of his body, could have killed him.
An abscess that ate away that much of his jawbone would have been agonizing. Turkana Boy is in so much pain, he's unable to continue the hunt. Knowing he would be looked after, perhaps he returned to his campsite to find comfort among the females.
I think he was probably a miserable fellow, in a lot of pain and very dependent on support and handouts. So it was a species that already felt that he's one of our weaklings that, we love and must protect and care for to have got him that far.
But however much they may have wanted to help him, there was nothing they could do about the infection that was probably spreading through his body.
From what the evidence suggests, I just always imagined him not knowing what was wrong with him. And there's a sadness to it. But ultimately from that comes this immortal being.
His skeleton was so complete, it is likely he died in water, which would have protected him.
It's very unusual to get a skeleton because normally these things are eaten by carnivores. And in this case, it seems that the boy's body was washed into a swamp, and so the carnivores never saw it and never destroyed it. And it gradually decomposed, and as the rivers flooded, brought in more sediment, buried it. And you could see footprints of hippos that had walked all over the bones, and some of the ribs and things were standing vertically instead of lying flat on the ground. And you could sort of reconstruct the situation and how the boy, what had happened after he died and why he was complete. It really was an amazing experience to see it.
For almost 2 million years, his bones were preserved by the earth. Their discovery opened a window for us on an unknown world. The world of the most successful human ancestor of all time, Homo erectus. They've revealed to us that mysterious moment when almost everything human was born. Our bodies, our minds, our emotions. Think of all we've become. Trace the threads of our origins through the ancestors who went before. They all lead back to Turkana and his kind, the first humans.
This NOVA program is available on DVD and Blu-ray at shoppbs.org or call 1-800-PLAY-PBS.
Humans. Without a doubt, the smartest animal on Earth. Yet we're unmistakably tied to our ape origins. Millions of years ago, we were apes, living ape lives in Africa. So how did we get from that to this? What happened? What set us on the path to humanity? The questions are huge, but at last, there are answers. More than 6 million years ago, we took the first step to separate from the apes. Since then, there have been at least 20 types of human ancestor in our family tree. Some of them were on their way to being us. Others were evolutionary dead ends.
As recently as 50,000 years ago, there were probably 4 different kinds of humans living at the same time. Yet today, we are a species alone.
Why did we survive and all the others disappear? New discoveries are shining light on the final stages of our evolution. We're finding out where our species, Homo sapiens, came from.
The genetic record shows us that all modern humans are descended from a small population of approximately 600 breeding individuals.
And we are discovering how they spread through the world, pushing out other ancient humans like the Neanderthal.
Neanderthals were very successful humans. They have lived in Europe for maybe 300, 400,000 years, but eventually they were replaced by modern humans.
But why were they replaced by modern humans? The mystery of the Neanderthal disappearance is finally being solved as the secrets of their genetic code are unlocked. We're discovering exactly what made them different from us and how we're unique. So join us as we explore the origins of our own species. Find out why we're the last humans standing, right now on Nova.
Major funding for NOVA is provided by the following.
Imagine a world with only a tiny number of us in it. Perhaps just a few thousand. A recently evolved species, we are completely at the mercy of the natural forces around us. 140,000 years ago, Homo sapiens teetered on the brink of extinction. New discoveries are revealing how, from these humble beginnings, we took over the planet, eventually replacing other ancient humans who were already living there, Homo erectus and the Neanderthals.
Humans have a very intensive way of using the environment. Humans move into the Middle East, the Homo erectus starts going extinct. When humans move into Europe, the Neanderthals go extinct.
For almost 400,000 years, the Neanderthals lived in Ice Age Europe. Superb hunters, they had brains bigger than ours and a record of survival twice as long. They were the most advanced humans on Earth until we arrived. And then they vanished. Why? Finally, we're unearthing the answers. The remains of a 100,000-year-old child are revealing what we had that they didn't.
Essential to figure out what are the differences between the Neanderthals and us to figure out what is special about us.
Was it some new physical ability? Or was it a new way of thinking? These questions go to the heart of what makes us human. To answer them, we must travel back in time to the beginning of our human story. Imagine the entire span of recorded human history, taking us back to the Egyptian pyramids 5,000 years ago. Double it 10,000 years ago, when plants were domesticated and agriculture begins. Double it again, to the time when Ice Age hunters paint stunning images on cave walls. And keep doubling 6 more times, and we are finally entering the world of Homo erectus, the remarkable ancestor who pioneered what it means to be human. Homo erectus appeared on the African plains almost 2 million years ago. They were the first ancestors who had bodies like ours. They were hunter-gatherers and tool makers, beings who lived in social groups and cared for each other. The most famous Homo erectus is the fossil called Turkana-Boy.
Well, Turkana-Boy and his ancestors, they represent a threshold. They represent that point in our evolution when we weren't quite fully a human, but we were no longer an ape.
Paleo artist Victor Dieck specializes in creating scientifically based sculptures of ancient humans from their fossil remains. As he reconstructs Turkana-Boy's head, ape-like features emerge. Heavy brow ridges, a protruding lower face, a skull still smaller than our own, But despite these differences, Turkana Boy is definitely starting to look like a human being. And behind those eyes, his mind was becoming human too.
I suspect that complex feelings and behaviors had their beginnings with Turkana Boy's kind, and that what it is to truly be a human had its bubblings at that point.
It was probably Homo erectus, almost 2 million years ago, who first started to leave Africa. Ever since, Africa has been the engine of our evolution, pumping out wave after wave ancient humans who populated Europe and Asia. Settling in far-off places, they developed in their own special ways. An early wave gave rise in Indonesia to the extraordinary hobbit, perhaps a type of dwarf Homo erectus. Another wave took Homo erectus all the way to China, where fossil remains have been dated to over 700,000 years ago. Soon after, another wave left Africa, this time heading for Europe. This was the species that would one day give rise to the Neanderthals. Ever since the first skull was discovered in Heidelberg, Germany, they have been called Homo heidelbergensis. But almost nothing was known about it until one extraordinary find was made. Atapuerca in northern Spain. These rolling hills have turned out to be an archaeological gold mine. When a railway was built over 100 years ago, it cut right through the hills. Archaeologists later discovered this had exposed over 1 million years of ancient human habitation, including the oldest human remains in Europe. Nearby, on the crest of one of the hills, they also found the entrance to some caves. To explore them took years, but it has been worth it. They have discovered a labyrinth of chambers and corridors reaching far inside the hills. At the end of the labyrinth is one of the most inaccessible archaeological sites in the world, a treasure trove of human fossils they call the Pit of Bones.
This is the entrance to the whole system. The pit itself is very far from here. It is a long way, and in some places you have to crawl. It's a difficult place to work.
Today, it takes half an hour of walking, crawling, and scrambling in the dark to reach the 50-foot vertical shaft that drops into the pit. But it took almost 10 years for the site to give up its secrets.
We started to find small pieces of human bones, difficult to recognize at the beginning because they were very fragmentary.
But so many tiny fragments made them think they were on to something big.
Even without talking each other, we started to think that maybe there were, down there, skeletons.
As bone after bone came out of the pit, they realized they had not one, but many complete skeletons.
We have around 30 complete skeletons, 500,000 years old. And this is absolutely unique.
These are the skeletons of the ancestors called Homo heidelbergensis, one of the earliest to populate Europe. But why were so many complete skeletons collected in one place? Juan Luis Arzuaga believes they were put there intentionally by their kin. 500,000 years ago, the pit of bones, now deep underground, had an opening to the surface. Perhaps Homo heidelbergensis dropped the bodies into the pit in a sort of primitive burial. And there is evidence it may have been ceremonial. Along with the bones, Juan Luis found a single artifact, a hand axe made of pink quartz, a mineral which must have been brought from a long way away. The team called it Excalibur, after King Arthur's famous sword. They believe it was an offering, the first symbol ever found. If this is right, here were beings with complex minds, capable of symbolism and belief.
500,000 years ago, in these European populations, there was planning, there was consciousness, there was a human mind, and there was also symbolic behavior.
We used to think these qualities belonged only to us, Homo sapiens, that the earliest evidence for them was in the painted caves of southern France, just 30,000 years ago. But the extraordinary finds at Atapuerca may have pushed the beginnings of that mental evolution back almost 500,000 years. Homo heidelbergensis would continue to evolve, eventually becoming the species who would populate Europe, the Neanderthals. Of all ancient humans, the Neanderthals were the closest to us. Their brains were slightly larger than ours. Their short, heavy-set bodies helped them survive repeated ice ages. They were hunters, living off the big game that roamed the edges of the great ice sheets covering Europe and Central Asia. When Neanderthal fossils were first discovered, Darwin had yet to publish his theory of evolution. The idea that modern humans had descended from more primitive forms would generate furious controversy.
Il s'agit du crâne d'Angie II.
This is the skull of Angus II. It is the first Neanderthal fossil ever found on Earth. It was discovered at the end of 1829. But back then, people were not happy with the idea that this could be a human being like us.
Many claimed that the Neanderthals were just diseased, misshapen humans. Then, as evolutionary ideas took hold, people wondered if they were the missing link between us and the apes.
If we go back to the beginning of the 20th century, Neanderthals were seen as sort of ape-like creatures.
But since then, hundreds of fossil finds have revealed their physical similarities to us.
After the 70s, there was a so-called rehabilitation of the Neanderthals, so we tend to see them in a more human way.
But did they think and act like us? Today, the remains of a young boy who died 100,000 years ago are helping researchers penetrate the mysteries of the Neanderthal mind. The Meuse Valley in Belgium. It was caves and rock shelters here that gave up the very first Neanderthal fossils 150 years ago. Today, they are revealing deeper secrets of the Neanderthal world. For over 20 years, Michel Toussaint and Dominique Bonjean have been excavating a cave called Sladina. One millimeter at a time, they've been sifting through the debris that once filled the cave. Their painstaking work paid off.
I've had the chance to be present when one of my students have discovered
Neanderthal child. And when we have come there and see that this piece was, we were so surprised, we couldn't believe.
What they uncovered was the jawbone of a young boy, 100,000 years old. Nearby, they found more fragments and teeth, until they had almost a complete mouth. Since then, they've been trying to reconstruct the life of the boy from Skladina. They know the woodlands and caves of the Meuse Valley were his home. He probably lived here with his extended family. Already, he would have been learning from his father the skills to become a hunter. But what else can we infer about his way of life? His bones are full of clues, and new techniques are allowing scientists to decipher them. Michel is taking a piece of the jaw to one of the few places in the world where the tests he needs can be done. The Max Planck Institute in Leipzig, Germany, is one of the world's foremost centers for human evolutionary studies. Here, the jawbone of the child from Skladina is put through a high-powered CT scan. This allows researchers to peer into the internal structure of the teeth and bone.
So this is the mandible that was scanned yesterday, the Skladina mandible. And we have built up what we call a surface model, which is basically a virtual representation of the mandible in a computer. We can separate all the teeth from the bone in the specimen. The features that we can explore show us how Neanderthal are similar to us in many aspects, but also how they are different.
The teeth of children are among the most prized of all archaeological finds, because only they can tell us how fast those children were growing up.
If we look at the pattern of eruption of the teeth, the Skladina child, by modern standards, should be about 11 or 12 years old. The second molar is almost completely erupted. But when we look at the internal structures of the enamel and dentine, it has been shown that it's in fact much younger. We know that this child died around 8 years old.
Although the boy from Skladina would have looked like us, he probably grew up much more quickly. That means he had much less time for brain development and learning. But is it safe to assume the Neanderthals were less intelligent than we are? The crucial evidence comes from skulls. Endocasts, impressions taken from the inside of Neanderthal skulls, have revealed brains with many similarities to ours.
When we look at the Neanderthal endocast, we find a frontal lobe that we can't really differentiate from modern Homo sapiens. The Broca's caps that have to do with the motor control, motor aspects of speech are thoroughly human in terms of their form.
So if the front of the Neanderthal brain is similar to ours, what about the rest of it? Today, scientists like Katarina Havarti are trying to measure fossil skulls with new precision. She uses a special instrument to digitize the skulls and create perfect three-dimensional images.
We've known for a long time that Neanderthals look different from modern humans ever since they were first discovered and described. But the question then becomes, what does this difference actually mean?
This is a digitized 3D image of our own skull, with its characteristic high dome. By contrast, the Neanderthal skull is low and elongated, possibly indicating a different brain shape. The parts of the Neanderthal brain, called the parietal and temporal lobes, may have been slightly smaller. That small difference could have had a large impact on their mental ability.
There are regions of the parietal lobes and the temporal lobes that are very important in cognition, particularly in terms of language, in memory, in remembering spatial locations.
The reduced size of those regions of Neanderthal brains might be a sign of limited thinking powers. But the boy from Skladina's jawbone has more to tell us about other limitations. Back at the Max Planck Institute, Mike Richards is delving even deeper into the microstructure of the bone to find out about his diet. The food we eat leaves a chemical signature in our bodies. These signatures are incorporated into the protein of our bones.
So what we do is get the bone and we take that protein out and measure those signatures. We can work backwards and say this is the food that this human ate over their lifetime.
He's discovering that Neanderthals were almost exclusively meat eaters, although there were many fruits, berries, and edible roots in their environment.
We don't see any evidence that plant protein was at all important in their diet. And it doesn't look like they had marine food at all. They were hunting large herbivores like bison or reindeer and things like that.
They were carnivores, with a diet closer to that of a predator, like a wolf, than a human. And they showed few signs of change, no matter where they lived.
So far, we've measured the type specimen from Germany, the Neanderthals from Skladina, Neanderthals from France and Croatia over about 100,000 years. And in every case, in all these different environments, the Neanderthals do the same thing.
So the bones of the boy from Skladina and his people are revealing important clues to Neanderthal behavior. They did one thing, hunting large game, and they just kept on doing it. For hundreds of thousands of years, their technology tells a similar story.
Neanderthal technology is quick and dirty. It's simple. There's very few tools that Neanderthals made that one can't copy in a few seconds or even minutes.
Although they hunted large animals, they didn't have throwing spears or arrows.
None of the stone tools that the Neanderthals made are of the size and shape sufficient to be a projectile point. They're all too big, which suggests they're either knives or tips of thrusting spears.
That meant Neanderthal hunters had to get close to their prey to kill them, which made hunting a risky business. Most Neanderthal male skeletons have multiple fractures. Neanderthal lives were tough and they were short. Their skeletons tell us that very few lived beyond the age of 30. But as a species, the Neanderthals were long-lived. They lasted for almost 400,000 years. That's twice as long as we have. But one day, their time on Earth would come to an end. By 25,000 years ago, they vanish from the fossil record. So what happened? To find out, we have to return to Africa. The Great Rift Valley, the stage on which so much of human evolution has played out. It was here, millions of years ago, that nature began its grand experiment with creatures like Lucy, who walked upright. It was here, just over 1 million years ago, that Turkana Boy and his kind, with their bigger brains and bodies, formed the first hunter-gatherer societies. And it was here, about 200,000 years ago, that the skulls of a new species start to be found. the last human to evolve, Homo sapiens. They are still not completely us. Their brow ridges are a little heavier, their faces a little bigger, and their technology is still simple.
If you have stone tools made by Neanderthals and stone tools made by Homo sapiens, and they're identical, you can't tell which one made the stone tools because they're making the same kinds of tools.
So what changed? What made us into the versatile beings we are today? All the evidence points to climate upheaval.
We enter one of the longest, coldest glacial stages on record.
Around 200,000 years ago, vast ice sheets descend. In Africa, mega droughts turn much of the continent into a desert.
And so basically you've got this double whammy of climatic challenges slamming the African population, and the people dwindle.
Geneticist Spencer Wells believes that ancient population crashes have left a footprint in our genes. It's called the bottleneck effect.
Humans, although on the surface we seem to be so different from each other, actually have remarkably little genetic diversity. We're 99.9% identical. You look at other apes like chimps or gorillas or orangutans, they have between 4 and 10 times as much diversity at the DNA level.
The lack of diversity in human DNA is a clue to a crisis that may have wiped out whole populations.
The reason that we have so little diversity at the genetic level is because we lost it at some point. Imagine that this bottle of jelly beans is the initial population. You've got so much diversity in here. What happens during a bottleneck? When you go through the bottleneck, only a few of the lineages survive. So that's the drop in population size right there. Everyone alive today is a descendant of these individuals, and you can see that we're missing many of the colors that you see in the initial population. That's how a bottleneck works. And everybody alive today is a descendant of that small number of individuals who made it through the bottleneck.
Ancient climate data shows that around 140,000 years ago, most of tropical Africa became uninhabitable. Our ancestors were forced to seek refuge on coasts and highlands.
It looks like 4 to 6 potential locations in Africa that would still be supportive of hunter-gatherer populations.
Despite the refuges, there is evidence our ancestors were pushed to the brink of extinction.
The genetic record shows us that all modern humans are descended from a small population of approximately 600 breeding individuals.
There's disagreement about the numbers and timing, but it does seem that all people on Earth are descended from a very small original population in Africa. Curtis Marion believes they lived on the South African coastline and that it was life by the sea that forced them to change. At Pinnacle Point, South Africa, he has found caves used by early Homo sapiens ancestors during the mega-drought period. They're full of clues that hint at new ways of thinking and behaving. Here, he has found some of the earliest evidence that humans were living off the sea.
This darkish material here is ash from a fireplace, and the vast majority of this material is burnt shell. So clearly there was quite a bit of cooking of shellfish that was taking place at this exact spot. 76,000 years ago. Somebody had a nice shellfish dinner there.
Here was a population that was broadening its diet away from meat, requiring ingenuity unknown among earlier ancestors.
You go out to collect shellfish at the wrong time, you're dead. You have to be able to time your access to the coastline so that you are here when the tides are right to collect those shellfish.
The best time to collect shellfish is at extreme low tides. And to predict those, it helps to understand the cycles of the moon.
Those are the times that you want to be collecting shellfish. All the shellfish are exposed. So this water, which you see here, is out there at that point where that rock is. So the smart coastal hunter-gatherer knows how to use the moon to signal to them when to come to the coastline to collect the shellfish.
The people of Pinnacle Point were not just harvesting shellfish, they were also hunting on the plains behind the coast and gathering berries and roots. Their way of life reflected a new versatility.
The systematic use of coastal resources does suggest a cognitive complexity.
Our ancestors occupied these caves for over 140,000 years, leaving behind an amazing record of their transformation.
This site documents a change in the way that people made stone tools. At the bottom of the sequence, they made stone tools with this rough quartzite material. And then right at about 71,000 years ago, which occurs just about there in the sequence, they make a shift to making stone tools on this silkrete in the form of long, thin blades. Before flaking it, the people here were heating this material in the fire, and through heating it, improved its flakability. And that was at about 71,000 years ago. About 40,000 years older than that has been found anywhere else in the world.
The technology of our ancestors was expanding from the single all-purpose hand axe to a variety of lighter, specialized tools.
Then they started to make these kinds of things. They made tools with special little points for perforating tasks. Like this. They made others with special little chisel ends for carving tasks.
Specialized tools allowed our ancestors to get more out of their environment. But this wasn't the only change.
And at this point, we begin to see people treating stone tools as symbols. They're making them more complex than they need to be to accomplish a particular cutting task. So at this point, stone tools are no longer just tools for cutting things. They're instruments of carrying social information about their owners.
A new type of symbolic consciousness was emerging. The first evidence of decorative art made from a naturally occurring mineral called red ochre has been found at Blombos, another cave along the South African coast.
While we were excavating more or less in this area you can see over here, we found a chunk of ochre, and when we brushed up the surface of the ochre, we realized that there was actually a design on the one side. And once we looked at it in more detail, held it up to the light, we could see a cross-hatched pattern that had lines zigzagged across the surface of this flat ground surface, and also had lines across the top, through the middle, and along the bottom. And you can imagine there was enormous excitement because we did not expect to find something that might represent a symbolic image in these 75,000-year-old levels. So this really was an enormous surprise for us.
At Blombos, they've also found shells with holes drilled in them, believed to have been used for necklaces. So our ancestors were now wearing ornaments and probably painting their bodies as well.
For me, what is really important is here, for the first time really ever, we have evidence that people can store information outside of the human brain.
It is the birth of a new type of human culture. More complex, but easier to pass on from generation to generation. "60,000 years ago, our ancestors emerged with new technology and new culture. Thousands of years of drought had forced them to change. They were ready to explore the world. As the climate improved, they started to stream out of Africa. They might have been surprised to discover continents already populated by other humans, remnants of earlier, more primitive migrations. As they moved into Asia, they might have come across Homo erectus, or the tiny hobbit. There's no evidence for such a meeting, but there is one encounter we can be more certain about. As a separate wave slowly moved through the Middle East into Europe, they must have met the Neanderthals. What were those meetings like? For many years, scientists speculated that early Homo sapiens populations absorbed the Neanderthals through interbreeding. If they did, there would be traces of Neanderthal DNA in our genes today. But there was no way to detect Neanderthal DNA until researchers at the Max Planck Institute set out on a daring scientific odyssey: the quest to sequence the Neanderthal genome. The human genome contains approximately 3 billion chemical bases, the A's, T's, C's, and G's that make up our genes. Mapping that was hard enough. The idea of mapping the genome of a long-extinct species seemed pure fantasy. But that didn't stop Svante Pääbo from dreaming about it. The first problem was to get DNA from Neanderthal bones over 30,000 years old. In most cases, DNA degrades steadily over time, leaving only minute fragments.
My group is involved since over 20 years now in developing techniques to retrieve ancient DNA from fossils and old bones. And of course, always a dream was to do the Neanderthal, our closest relative.
But finally, taking great care not to contaminate it with their own, they isolated the first piece of Neanderthal DNA. Svante's dream is now a reality. He and his team have made a draft of the entire Neanderthal genome. Now scientists all over the world can compare key parts of it to the human genome. And one such comparison is already giving us deeper insight into the Neanderthal brain, the gene called FOXP2.
It's the only gene we know of today that's involved in speech and language development in humans. We know that because if one copy is lost in a human due to a mutation, we have a severe speech problem.
When first discovered, FOXP2 created a lot of excitement. Although many animals have the FOXP2 gene, the human version is unique. Some thought it was the gene for language. We now know that complex traits like language are controlled by many genes. Yet researchers agree the human version of FOXP2 is closely tied to some of the basic motor skills necessary for speech.
And the big question was, of course, is that shared with Neanderthals or not? And when we now look at it in the Neanderthal, indeed, it looks to be identical with us.
It's tantalizing evidence that despite their mental limitations, the boy from Skladina and his people may have been able to speak. If we share the capacity for language with the Neanderthals, could we both have inherited it from the same source? A common ancestor who gave rise to both species. Who was it? With a technique called the molecular clock, scientists can now find out. That's because DNA mutates or changes at a surprisingly regular rate. By counting the differences in the genetic code of Neanderthals and ourselves, simply comparing the A's, T's, C's, and G's in our DNA, scientists can calculate how long the two species have been diverging.
We can then estimate when there was a common ancestral population, where some individuals went on to become modern humans, some went on to become Neanderthals. It is in the order of, say, 300,000, 400,000 years ago.
The timing points straight to the intriguing ancestors who left Africa 500,000 years ago and buried their dead in the hills of northern Spain, leaving a distinctive pink hand axe at the spot. This is Homo heidelbergensis, who we now know is our ancestor too. In Europe, they evolved into the Neanderthal. In Africa, groups that had not yet migrated evolved into Homo sapiens. So DNA is revealing we share a common ancestor with the Neanderthals. But do we carry some vestige of Neanderthal DNA in our genes? Proof that we absorb them by interbreeding.
Some people claim that there are some hybrids of Neanderthals and modern humans. In the genetical record, we don't see clear evidence of that. The big story is that there were Neanderthals, they were replaced by other people, and after a rather short time, we don't see any trace of the Neanderthals in Europe. And certainly today, we don't see really traces of Neanderthal genes.
With no evidence of interbreeding, it now seems more likely that as our population grew, we simply pushed the Neanderthals out of their environments.
Humans have a very intensive way of using the environment. We seem to have the ability to pump out lots of babies, and our babies seem to have a high probability of surviving. So population growth is a really important part of the human adaptation.
The arrival of Homo sapiens was not the only thing the Neanderthals had to contend with. Europe was gripped by wild climate swings. The Neanderthals were already struggling to survive.
Probably the density of Neanderthals in the landscape was very low.
And there was a good reason for that. Neanderthal technology was limited, and their energy needs were huge.
They had this big body, this big brain, living in a rather cold environment, so we have estimates of their energy consumption every day. It's about 5,000 kilocalories. It's about what someone racing the Tour de France is spending every day.
But with slimmer, taller bodies, modern humans had lower energy demands and an ever-improving toolkit. They now developed yet another breakthrough technology: projectile weapons, throwing spears.
These are two very different kinds of spears. These are the big, heavy wooden spears that Neanderthals and their ancestors used. These are the lighter, bone-tipped spears that Homo sapiens used. These weapons have different kind of performance characteristics. The heavy spears are effective, but they're effective at a very short range, and they're heavy. You can only carry so many of them in one hand. The bone-tipped spears are lighter, they're more durable, they have a longer effective range. In essence, the bone-tipped spears that our ancestors used allowed them to hunt a wider range of animals more safely, and therefore to have a broader ecological niche. These big, heavy spears with their weight, their relatively short range, it's like hunting with a pistol. Whereas using these things is like hunting with a semi-automatic rifle. One has more than one shot, one has greater range. It's a more effective weapon.
Throwing spears allowed our ancestors to go after a wider range of game with less risk to themselves.
The modern humans have this trend of intensifying their exploitation of the environment to sort of squeezing out everything possible from the environment.
That trend, already established in Africa, would become more pronounced as our ancestors spread around the world. Archaeologists have been able to track their movements by the extinction of large animals. In Europe and Asia, the arrival of Homo sapiens coincides with the disappearance of the hairy mammoth, the cave lion, and other large mammals. In Australia, most animals weighing over 100 pounds vanish within a few thousand years of our arrival.
The effects of Homo sapiens on large animal communities become more profound as you move further and further from Africa. So very few major extinctions in Africa, a few extinctions associated with Homo sapiens moving into Eurasia. And then when they hit Australia and the New World, it's a wipeout.
The Neanderthals were just one of many species that disappeared when we arrived. Gradually, they were pushed into marginal areas of Europe. Their last refuge seems to have been the Rock of Gibraltar 28,000 years ago. Then, they vanished, leaving no legacy but their fossilized bones. For the first time, there was only one type of human on the planet.
But this species, it covered the whole planet. It went to places where other hominins lived. It led them to extinction, actually. They went to Australia, they went to Americas, they went to the moon, and they will go to Mars. And this is very peculiar because the way this species intensify its exploitation of the environment is really unique.
In the beginning, climate upheavals made us what we are. They taught us a new inventiveness which has led to a cascade of technological advances. But exactly what made us different is still an enigma. Soon, we'll discover the genetic changes unique to our species. But genes are only part of what makes us special. The other part is that mysterious creation, unique to humans, culture.
Homo sapiens is the most adaptable species in the human career, meaning that no matter what happens in the world, we have a way of adapting to it. Today, that way is called culture. If glaciers came to Arizona, where I live, we wouldn't be growing thick fur and thick skin. We would be building more fireplaces and heating systems.
Culture is the storehouse of our complex ways of thinking and perceiving. And we pass it on to our children as surely as we pass on our genes. The ways in which cultural evolution and genetic evolution interact will be at the forefront of the research of tomorrow. Because one thing is for sure, evolution is not stopping.
The rate of evolution at the genomic level has increased over the last 10,000 years, and it probably will continue over the next few thousand years.
Where it will take us, nobody knows. But we're still a young species. There is a long future ahead.
This Nova program is available on DVD and Blu-ray at shoppbs.org or call 1-800-PLAY-PBS.
In the summer of 2009, a young Iranian woman was killed at the height of protests over the presidential election. The incident became a source of international outrage. Stay tuned for A Death in Tehran.